Hello! In this video we're going to talk about our new data logging system Log.flow and how to use it together with the EasyGraph software. This video is meant for anyone who is not familiar with it and should get you started quickly if you follow me along. First, we'll do some simple setup on the computer, and right after this we'll go out to do some recordings at our test benches. After the example applications, we will also cover some more tips and tricks with EasyGraph. We also added some time markers for you to jump there quickly. But first of all, we have to talk about what Log.flow actually is. Log.flow is a small and portable but powerful data logging system to be used with flow meters or similar devices. With the PC software EasyGraph, you can record and analyze your fast-moving dynamic processes, or you can also do long-term recordings. There are 3 versions of Log.flow, the standard version with the 2 frequency inputs, and 2 versions with 1 frequency and 1 L-log input. In the box you will get the Log.flow itself, M12 and USB cables, some T-connectors, a power supply, and the EasyGraph software license. Now we're going to install the software and prepare our connection to Log.flow. For this we will need a license certificate in order to download the software from our homepage. There you will find a link to log in, and you can enter your customer ID and your serial key. With the downloaded file you can then install the software, and after the installation process you can open the software by double-clicking on its icon. Before you can connect to your Log.flow device, you have to enter the license key into the software also. For this you go to Device, Log.flow and Edit Serial Key, enter your key, click plus, click on the key and close the window. And you can see we're successfully connected. If at any point you need any help or the documentation, you can find it in the help menu. And in this documentation you will find everything about how to connect your inputs to the device, how to connect different devices to EasyGraph, and any other information about the specific features of EasyGraph. Now we will start with some applications, and the first one will be how to analyze flow rate and pressure at our pressure test bench. With our pressure test bench we can simulate pressure and flow simultaneously. Internally it uses a variable frequency drive with some valves like a pressure control valve and an RS flow meter, and we're going to tap in with 2 T-connectors into the pulses of the flow meter and into the pressure of one pressure transmitter. And yeah, here we go. So the RS has a little connection there for a pressure transducer. We'll just undo the little plug there and put in the Sucre pressure transmitter and screw it on tightly. And now we get our Log.flow demo case, and we have this Log.flow I version, which is the 4 to 20 milliamps input. And we're going to connect it to our pressure sensor and to the preamplifier of the flow meter. But we have to make sure that the pinout of the pressure transducer is correct. So when we look back onto the pressure transducer on the back, you will see the pin is on pin 3, but the Log.flow has its analog in pin on pin 4. So we need to build a little adapter cable, and then we're ready to go when we just plug it in, and we'll put the pin 3 of the sensor to pin 4 of the Log.flow. Now we'll just use the included USB cable to connect Log.flow to our PC, and we can start the pumps of the test bench. In the EasyGraph software we're now going to set up our flow meter input. For this we go into Device, and we can change the input configuration, for example to single channel. In this example we set it to single channel because it was going to the wrong direction. We can adjust the history a bit to our liking and adjust the filters, so we will see more dynamic fluid phenomena. For our pressure sensor we will need to adjust the input configuration to 4 to 20 milliamps. And then we'll go into the math menu and set up the calculation, gain and offset values, so we'll see the bar value in the right unit. So we'll just calculate the 600 bars into the 16 milliamps, and we get a factor of 37.5. And for the offset we'll be calculating 150 minus. And then we can just adjust the unit to be bar, and we will have the correct value shown on the right. Just add some decimal places here. To start the actual recording, we're going to press the record button at the top, and we're turning on the test bench and adjusting the pressure control valve. On the graph, you will immediately see the pressure going up here, and at the same time you will see the flow rate in red, which has some fluctuations in there when the pressure is adjusted. And now we're modulating the frequency of the frequency drive. You can see the frequency going up, and we'll also see the fluctuations in the flow and the pressure. So when we now adjust the pressure again, we'll also see a little dip there in the flow rate. And now we're just modulating the pressure up and down, so you can see the influence on the flow rate. Now we turn off the flow and we can stop the recording. And when we double click on the file on the bottom right, we can just analyze our plot. We can use the right mouse button to zoom in and analyze all of the tiny little peaks we have there. And now we're going to the second application where we use EasyGraph and Log.flow to record two flows simultaneously. For this, we're going to use the normal Log.flow standard version. And we're here at our calibration test bench with the two flow meters in series. And we will just record the whole calibration procedure of 1 point. And in this case, this is how the test bench looks like. We'll use the T connectors again to tap into the master and device under test flow meter with Log.flow and record the whole process. So now we'll just grab our Log.flow case with all of the accessories. And here we have the Log.flow itself. And we'll use the included T connectors to connect to the device under test. And just connect it, and then we can use the included M12 cable to connect to the Log.flow and just tap into the system. And at the same time, we'll just use the T connector to connect to the master, and then we'll have both flows in the Log.flow. In a situation like this, you'll usually get power from the test bench, but if you need more power for your flow meters, you can just use the included 24-volt power supply, and we'll just add the USB connection here to plug it into the PC. So again, we're using EasyGraph and connect to the Log.flow to start the process. Here we'll adjust it for the VSI flow meters, which are two quadrature inputs. And for now, we're setting the filter to dynamic, but we'll show you how to adjust it later. Within the mask settings, you will find a database of all of our flow meters, and you can easily select the flow meters that you're using and adjust the interpolation factor, and you will just like this have the factor and the offset here. And then you do the same for the second flow rate, which is a VSI 0.2 with an interpolation factor of 16. And now we have to do the same thing again for the volume. So for the master, we will just choose the VSI 0.2 with an interpolation factor of 1. And for the second volume, the same flow meter with an interpolation factor of 16. As a general side note, if you want to adjust the plot in the plot view, you can just use your mouse, you can scroll to zoom out, you can click and drag with the left mouse button to adjust the plot, you can use the history slider at the top to adjust how much time in the past you want to see. And now we're just going to start the flow on our test bench, we'll see the flow meters go up, and yeah, we'll just see the process on our live graph. Just hit record, reset our volumes, and you will hear the pump starting to the calibration point at about 6 liters per minute. As both flow meters are in series, you will see both lines behind each other. So the master flow meter will be the red line and the blue line is the device under test. And at the bottom in the cyan and purple lines, you will see the volumes going up. So now the flow is stabilizing and the actual calibration is going on in the background, and after the point is measured, we will see the flow rates go down again and approach zero flow again. In the meantime, let me just explain a bit the features at the top. You will see the settings auto scroll, auto scale and log min. The auto scroll is the thing that you see right now. You will see the time go and the graph will go to the right. The auto scale is just automatically scaling the view so it will fit all of the lines. So like when the flow goes out of the bounds of the display, it will just rescale the axis. And the log_min function goes hand in hand with the auto scale and will just lock the minimum value there at 0 while scaling only the top value. Now I stopped the recording, double-clicked it, and now we can use the right mouse button to click and drag a yellow box, which will zoom into this section, and we can just check out the interesting points of the calibration, like the end of the calibration, or at the start we can see the behavior of the flow meter at the startup, and here you can really see the difference of the interpolation factors. So the blue line will be the 16 EPF, and the red one will be the other flow meter. To automatically scale the whole plot into the window, you can just double-click on the axis. If our application is not too dynamic, like in this case, we can adjust the filter to be more aggressive by just using the slider in the device menu. When we put it higher, we will see a more stable reading here, and this will be better in our case. We can also turn it off, but this is very noisy. So we'll just find a good balance here, and we'll have a way more stable reading. In our next example, we are going to record dosing shots with a pump and a flow meter in series, and it's about dosing small little dots, for example, or like the same volume over and over again with high repeatability, and we want to track the repeatability of the whole process. So at the bottom of the data logging menu, we'll have a dosing mode checkbox, which you can enable. And then we have a few settings like the zero flow tolerance, when it will automatically reset the volume. We can set the reset behavior and also set the duration, after which it will automatically reset the volume. When we now hit recording, it will be a little bit different. And we'll now simulate some dosing shots here, and we'll have a log flow with an log input to show also the pressure. And we have on the first channel of flow, and the purple line is again the volume, and you will see it counting up. And after each shot, it will automatically reset the volume and get the last value that was on the volume counter and put it into the Excel file. So we will get a positive volume, we will get a retract volume, and we will get like the maximum pressure that occurs during the whole dosing shot. And when we have our 10 dosing shots recorded, we can just hit recording again to stop the recording. And right-click on our dose file, set some parameters like the flow meter name and the sensor maybe. So we'll have a little bit of documentation in our file. And there's also a field for an info. And when we now save it as an Excel sheet and open it up, we'll have a nice table of our recorded data, which we can then further evaluate to, for example, make a diagram or do some more statistical analysis. So that's it for our applications. Now we'll just go into some tips and tricks with EasyGraph. And now I'm going to show you how the trigger functionality works. You will see the trigger here and at the data logging menu. And you have some configuration options. A trigger is something that will automatically start recording when a certain condition matches. So here we'll set the trigger mode to repeating, so it will go off multiple times, not only once. We can set a recording time of 5 seconds and also a pre-trigger duration, which is the data which is also in the recording file that happened before the trigger happened. Now we have the trigger condition, which will be flow rate 1. We want the condition to be when the flow rate 1 is above a value of 1000 Hertz, for example. And yeah, for now we'll just enable the trigger and we'll see the trigger line here, which we can also adjust by clicking and dragging here. So for example, we can set it now to 800 Hertz. And when we now modulate our flow a bit and we will just reach the trigger line, you can see the trigger is active at the top, and yeah, the red line is still below the trigger line. Nothing will happen, no recording will start, and it's still waiting for the trigger. But if the red line crosses it, you will see the little start at the bottom and also recording going off. And the recording will automatically stop after 5 seconds. And when we hit the line again, it will start a new recording. So this is how the trigger works in theory. For more complex triggers, you can also do a second trigger condition if you want. For example, we can leave the first trigger condition as is and add the second trigger condition with an AND. For example, when the second flow rate is below 0, for example, and the flow rate of flow rate 1 is above 800, then it will trigger, not in any other case. So when we now leave the second flow meter value above 0 and hit the line at the top, nothing will happen, no trigger will happen. But when we go below 0, the blue line, then the trigger will really trigger the process. We can use this to combine both channels. And it's not only possible to use the AND operation, you can also use the OR operation, for example, to trigger on like the pressure of the analog input and other stuff you can think of. As a result, you will get multiple recording files which you can view and analyze, and in these files you can see also that we have the pre-trigger duration active, so we have a bit of recording just before it even happened. So like here is the 800 trigger mark, and you will see it's about at 2 seconds because we specified 2 seconds pre-recording time. The next feature is the cursor feature to analyze our live graph a bit more. And yeah, at first we'll just make some dynamic recording to view later. We'll just stop the process and adjust our view a bit to really see it. And now we can just find a spot that's interesting to us. For example, here this peak is very interesting, and we'll just use the bottom on the right, enable cursor measurement, to enable the cursors. And we have the time cursors, which are the vertical ones, and we have also value cursors. We have to specify the right channel we want to analyze. In this example, we have flow rate 1 as a channel. And we can use the time markers to adjust it to our section that we want to measure. So here we'll see the minimum value that happens between the time cursors, the maximum, the average, and also the delta between the maximum and the minimum. When we set it to the analog value, for example, it will measure the green section and will take into account all samples that are in this time zone. And yeah, you can see, for example, the maximum is at 78 about. And when we use the cursor to manually do it, we can also see it's about at this value, but the bottom value will be more accurate in this case. A major usage of EasyGraph is it to just record something and then show it to somebody else. So we included a little PDF export feature where you can just make a recording of something and then export it as a nice graph, which we can then print out or just send to somebody per email. And we can add some other information here to our recording. We can specify the inputs and also the name of the recording, some additional info. The flow meter names and also the date and time are included. And when we then export this as a PDF, we'll get a nice A4 paper, which will show the graphs, the both channels that we enabled, and also all of the information we specified. With EasyGraph, you can not only use the Log.flow devices, you can also use other devices we have, like the IO.flow, for example, and connect them to the software. And for this, you will need the IO-Link USB master. And then you can just use it to connect to the IO.flow and connect it to the PC. And you will need a special license key for this, which you can also get at our place, and just activate it just like the other key. Just put it in there, ++, and then you're ready to connect. In the case of IO.flow, you will get a flow rate and a volume output, just like you specified it. So when you now turn the gears, for example, of your flow meter, you will just see the flow rate and the volume. And you can do all of the same things. You can record, you can use triggers, everything. And here you will have the A350, for example, which we can connect using the RS-232 interface. We just need to turn on the device, connect it, and check which COM port it is attached to. In this case, it's COM port 10. And in EasyGraph, we can just go to Display FU, select the COM port, and it will connect. So These devices have a little cooldown, so when you press start at the top, it will take some time to start, but then you will stream in very dynamic display values of the device itself. Thank you very much for watching this video, and I hope you could learn a thing or two, and yeah, see you in the next one.